Hello, everybody, and welcome to our webinar today on smart salting strategies for municipal departments of public works. This is a session that is a part of a greater national initiative called Winter Salt Week. So where are we in the grand schedule of events for Winter Salt Week? We are on Wednesday. But on Monday and Tuesday, we also had two webinars that went over more of the background of road salt, why it's a problem, and some of the ecological consequences to our oversalting and increasing freshwater salinization. Today, we will hear a more technical look about how municipalities can work to reduce their own salt footprint. Tomorrow, there will be a policy solutions panel at 1:30 p.m. And then on Friday, we have a statewide snapshot. So New Jersey Salt Watch is a project that we started at the Watershed Institute back in 2020 to engage the help of volunteers to learn more about the impacts of road salting on our freshwater chloride levels. And so our goal on Friday is to gather as much data as we can, have all of our volunteers go out to collect data so that we can get a nice, clear picture of what's going on throughout the state under the same sort of weather conditions on the same day. But if you want to learn more about any of those things, njwatershedwatch.org/saltwatch. You can find links to all of these presentations and learn more about New Jersey Salt Watch as well. I should mention we are still accepting volunteers with the New Jersey Salt Watch project. You won't get your test strips in time for the Friday snapshot, but you can certainly request them to start monitoring from now all the way until the end of April. And for today, just some quick notes. This webinar is currently being recorded on Zoom and live streamed on YouTube at the Watershed Institute's live stream channel. So this webinar will be available after the fact for viewing and to share with your friends and colleagues. For those of us in the Zoom world right now, please use the Q&A function if you have any questions as we go. And then, of course, again, if you have any questions about New Jersey Salt Watch or Winter Salt Week, head to njwatershedwatch.org/saltwatch. And so now I'm going to pass it off to Rich Balgowan. He'll be presenting our webinar today. Rich has 35 years of experience in highway and municipal engineering. He spent, I think it was 27 years with the New Jersey Department of Transportation, and then 6 years with the Hamilton Township as the director of their Department of Public Works. So he's got lots of expertise to share with us today, and I'm just so thankful that he's here with us. So Rich, you can go ahead and share your presentation and take it away.
Okay, are we good?
Looks great.
Okay. So my name's Rich Balgowan. I'm a licensed professional engineer in 12 states. I've been involved in snow and ice control for pretty much my entire career. 20, almost 24 years with the New Jersey DOT, a little over 6 with Hamilton Township Public Works. And in my current practice, I do forensic work. So I get a lot of cases for attorneys involving snow and ice control and that type of thing. So it's something, and I've been involved on state, national, international committees for snow and ice control since as early as 1996. I teach courses for the University of Wisconsin and also Rutgers University on snow and ice control. So something I'm very, very well versed in, and I'm hoping I can share some of my knowledge and experiences with you, and maybe you can implement some of these things. And I have some ideas on how to, to make it as inexpensive as possible to do. It's actually not as expensive as anybody might think. And so I'll get started. So I'm going to do this presentation on minimizing the environmental impacts of winter operations. Chlorides do a tremendous amount of damage to our environment, and we apply far more than we need to. And we'll get into that as we continue. So, okay, doesn't want to advance. Okay. So environmental concerns, not just with applying chlorides, but with also applying, other things like abrasives, which people still use abrasives. So I was riding down the road the other day on 295, and a truck went off the road and into the shoulder. There was so much salt in the shoulder, just this huge cloud of dust came up and definitely impacted sight distance. Water pollution from runoff, we're going to talk about that and how much salt that you put down on the road actually stays on the road and how much goes off into the natural environment. The damage salt can cause not only to our waterways, which impacts aquatic life and all that other things, but the damage it also causes to plants and soils and also our infrastructure. So environmental concerns, chlorides, acetates, and abrasives placed on pavements during snow and ice control operations eventually end up in the natural environment. That's a fact. The accumulation of chlorides, acetates, and abrasives proves risks to public health, aquatic ecosystems, water quality, vegetation, and wildlife. Chlorides cause damage to infrastructure. I'm going to have some photos showing all this stuff. The most common chemical used is sodium chloride, this common rock salt. It's the least expensive that's out there. There are many, many alternatives, but sodium chloride is the least expensive, and that's what pretty much everybody uses, typically mixed with something else. Other chemicals used either alone or in combination with sodium chloride include calcium chloride, magnesium chloride, very, very common, and potassium acetate, which you would typically see used at airports because it's non-corrosive. Calcium magnesium acetate, another non-corrosive material, but expensive. Urea, and there's agricultural byproducts, which we will talk about a little bit about. Abrasives are not chemicals, but are used at times to improve traction and friction, trying to make like sandpaper on the road. If you've lost things, kind of lost it, and you got away from anti-icing, you can get snowpack on the road. So if it's hills and intersections, abrasives can improve the friction for vehicles, give them a better chance to stop. In the United States, approximately 10 to 25 million tons of sodium chloride is used annually, depending on winter conditions. This is from the National Research Council. I'm sure you can find this on the internet. Studies have shown that 55% of road salts end up in our drainage systems and waterways. The remaining 45% infiltrates soils and into groundwater aquifers. Once salt reaches these aquifers, it remains there for decades. So you can see a lot of people don't know this stuff, and they just keep applying salt at rates that aren't necessary. And we're going to talk about what is appropriate as far as application rates and such. Acetates cause oxygen depletion in soils and water. Abrasives, use of dry abrasives for snow and ice control has very little value other than improving the friction. So if you, like I said, if you get snowpack or ice and you want to improve the friction, you can put abrasives down. Others try to cut through that snowpack or ice by applying salt, because now you're in a de-icing situation versus anti-icing. And we're going to get how much additional salt it takes to de-ice versus anti-icing. We'll get into that. An Oregon DOT study found that 50 to 90% of applied abrasives, this is sand, remains in the environment even after a cleanup. And that's why if you're near like little over culverts, you often, if you look down in the waterway as you cross over the culverts, you often see like little sandbars and things like that. A lot of that is from the abrasives that being applied to roadways. Not as much today, but in the past, abrasives were heavily used. Air pollution. Abrasives cause air pollution. There are things we can do to reduce air pollution. Again, this is a little more above the waterway thing, but anti-idling policies, alternative cleaner burning fuels, use biodiesel, ethanol, E85. When I was with Hamilton, I wrote a green fleet policy. So everything that they had to buy had to be something that burned a cleaner burning fuel. And we were using a lot of ethanol, which is 85% ethanol and 15% gasoline. And these flex fuel vehicles could run on any amount. They could run on straight gasoline if they wanted to, but they could run on 85% ethanol too. And that's cleaner for the environment. And there's hybrid vehicles, things like that. Plowing and spreading plants to optimize the use of time and fuel. We'll get into that. So water pollution, 2009 study by University of Wisconsin. This is where we are now. It's getting worse and worse and worse every single year because it's just if you're driving down the road and after a storm, you will see a lot of the roads will just be white, especially the state highways will be white. And if you look into the shoulders, you'll find all this loose chlorides that never went into solution. And that ends up just at some point migrating off into your drainage system and things like that, and can be very, very harmful to aquatic life. And now in some cases, you're even getting the effects of tasting it in some of the drinking water. So I kind of covered that. Other things that are used in salt are anti-caking agents. And some of these anti-caking agents, like Prussian blue and yellow prussiate, actually contain cyanide. There's agricultural byproducts that can be added to salt, which we're going to talk about because some of these are very, very effective at making liquids, like if you're pre-treating your roads, making them last longer and work better. Sugar beet juice is a very, very common one. We'll get into that a little bit. So equipment washing. So I don't know, for those of you who are actually involved in snow and ice control, in the old days, you pull your trucks in and after a storm, you just wash them all down. All the salt water would just come out and just go to find a storm drain. And that's not a good thing. So when you wash your vehicles, a lot of agencies now are actually putting in vehicle wash stations. And you can put your vehicle in the vehicle wash station, then everything gets recycled. The water gets recycled, doesn't go into the storm drain system. And I even think they recapture the salt that you're being washed out of there. Hamilton has a truck wash station, and they allow other towns to come and use their wash station. Otherwise, you should do things to prevent any water from getting into storm drains using, socks. So those big environmental socks, whatever you can get, but it shouldn't be allowed to go into the storm drain system. It's going directly into waterways. Salt storage. Again, salt storage. A lot of agencies it used to be you just have a pile of salt out there. But now you have salt barns and things like that. Well, you got to make sure that the salt stays in the barn and isn't allowed to get out and leach into your storm drain system. Here's a picture of a barn. This is just an old-fashioned one. You see the salt, and then right out front of the salt barn, you can see a storm drain, and you can see white there. So there's salt being migrating into that storm drain. Groundwater. So groundwater, we get groundwater. You got snow melt, and that gets in the lakes and streams. It can cause contaminated wells. I know in North Jersey we had lots of issues with wells getting contaminated with chlorides. A lot of them were blaming cracked floors in domars, big salt storage buildings. Once salty, it typically takes decades for the salts to disappear due to the slow travel times in groundwater. Damage to vegetation. So I think I took this photo, I believe it was the Garden State Parkway, and there's a lot of vegetation that isn't really salt tolerant. So salts that get off the road can kill vegetation. So you can see the amount of vegetation that's died here. And this was diagnosed as being caused by chlorides. Salt solutions can disturb water uptake of roots and cells and leaves. Salt spray can dry out leaves. Most damage occurs within 30 to 50 feet of the road. Susceptibility to damage by salt varies significantly among plant species. So a lot of agencies are, finding a way to put in salt tolerant species. But the bottom line is there's still all that salt going over there. So a sodium ion from salt will raise the pH of soil, causing soil to become muddy and denser. Chloride ion forms complexes with heavy metals in the soil and releases them into the environment. So now infrastructure damage from chlorides, again, not directly, this is not related to water, but this damage to sodium to infrastructure is significant with chlorides. And there's a lot of reasons for that. But this is just one example where you can see, the bridge paint is rusting, the steel is rusting. The United States Environmental Protection Agency estimates that for every ton of salt costing $50, now that number's old. Typical salt, like pre-treated salt, if you were to buy Clear Lane or something like that, that's somewhere, I guess, if you buy it off a state contract, somewhere around $75 a ton. Approximately $750 in damage to infrastructure. So that would be more on the lines of like $1,000 damage, and that includes concrete and vehicles and all those things. So here is this is a photo I took. I was a construction manager on the Garden State Parkway for a bunch of bridge rehabilitation projects. So this is where there's a joint in the bridge, and the joint was not properly sealed or functioning properly. So all the water and chlorides that got on the bridge leached down and got onto these beams. So here's a beam with a hole in it. And you can see the amount of rust and steel that has dropped down onto the flange of the beam. Another photo. What can we do to minimize the environmental impacts of winter operations? Well, you can develop a winter operations management plan. This is where we establish levels of service for different types of roadways, develop specific route-by-route snow and ice control plowing and spreading plans. We're going to get into that a little bit because it's so important to anti-ice versus de-ice. So if you have a plan to spread your roads at a specific frequency, you can maintain an anti-icing policy throughout the storm. And that means you have to have a route-by-route snow and ice control plowing and spreading plan in place, so everybody knows exactly what they're expected to do and how long it's going to take. Incorporate technologies such as automated vehicle location systems, geographic information systems, infrared mobile thermometers. We're going to get into that because infrared mobile thermometers tell you what the pavement temperature is, and the pavement temperature is a critical piece of information for you to use if you're going to maintain an anti-icing policy. So for example, I remember when I was with Hamilton Township, we had infrared mobile thermometers. We had pavement temperature specific weather forecasts, and other agencies were out there spreading material down for a storm. We didn't spread 1 grain of salt. And the reason was because we knew that the pavement temperatures were above freezing and weren't going to be going below freezing. So we didn't do anything. The snow landed on the road, the snow melted. And that was it. We didn't apply a single grain of salt. And that happened more than once. Adopt an anti-icing policy. Again, we're going to get into that. But that's extremely important. Anti-icing means preventing the bond of snow and ice to the pavement. De-icing means the bond has occurred and now you're putting salt on top of that. So anti-ice, you should be using pre-treating your roads with liquids if you can. If you are a shopping center owner, you can use solids, but you put the material down before anything falls from the sky. And that is essentially your first application of chemicals. And then you come back and you monitor it, and then you apply additional chemicals if you need to. Using pre-wetted material instead of dry. So I think just about everybody's doing this now, but if you were using just straight salt, sodium chloride, and applying that to the road, 30% of those chemicals are going to be displaced due to traffic. And this is for road due to traffic, wind, all that stuff. Pre-wetting allows the material to stay on the road longer. So pre-wetting is where you just take sodium chloride and you either have mixed in some kind of a liquid with it. Magnesium chloride, calcium chloride are the most common, and it will help the material stay on the road. If you don't do that, then this Michigan study showed that at least 30% of the chemicals, dry chemicals placed, end up going off the roadway and doing absolutely nothing except damaging the environment. Apply the appropriate products when needed at the right application rate and at the right time. Use pavement temperature and pavement temperature forecasts. Use technology to assess actual conditions when making decisions to reapply chemicals. And a lot of us, especially in the old days, It was just intuitive. You put your chemicals down, and then you decided, just based on your intuitiveness, when to reapply chemicals. Well, there's technology available now that'll tell you what the salinity of the material, the brine that's on your road, what the salinity is, what the pavement temperature is, and when you should reapply chemicals and how much you should reapply. Monitor operations and application rates. So I know when I started with the township, I was following a truck, and I estimated they were putting down more than over 800 pounds per lane mile of salt. And there were reasons for that. Either the driver felt more was better. He had control. More was better. And also the equipment wasn't properly calibrated. So calibration, very, very important. Make sure you calibrate your spreaders. So if you want to put down 300 pounds per lane mile, you're going to put down 300 pounds per lane mile and not 800 pounds per lane mile or 100 pounds per lane mile. So calibration, extremely important. We're going to talk a little bit about maintenance decision support systems. This takes some of the decisions and makes it more systematic and consistent. And it can always be changed, but it's a system that gives you guidance based on the information that's available, whether weather forecasts, precipitation intensity, pavement temperature, etc. Equipment use state-of-the-art spreader controls. There's spreaders out there. Most of these spreaders are now very, very intelligent, and they collect the data. They can store the data. Application rates, all those things can be stored in there, and then you can get access to that data through various means. Zero velocity spreaders are something where the actual spreader part is lower to the road, and it minimizes bounce. And I said before, calibrate and recalibrate equipment. Calibrate your equipment at minimum once per year before the winter, and ideally one other time during the winter. What we would do with Hamilton, we would try to do it that way, where we bring trucks in twice a year, but also when they came in for work, if they had oil changes or things like that, we'd also recalibrate them at that time too. Snow disposal, clearly don't dump snow that you're moving, picking up with loaders and stuff. Don't dump them into waterways. And that was a standard practice at one point, just to get rid of it. Minimize the use of abrasives. Abrasives have to be in your toolbox, but there's no reason to use abrasives unless it's to create like a sandpaper situation, typically where you're on hills, where you're no longer in an anti-icing situation, where you've got pads or ice. Abrasives, you try to make sandpaper to improve the friction. But abrasives have no melting ability and should not be used very often. Anti-icing, extremely important. That's what everybody should be doing. Housekeeping, washing equipment, already covered that. Make sure that you don't allow wash from your runoff from your washing activities to go into the storm drains. Salt storage, make sure your salt's covered. Make sure there's doors or shields on the front so salt can't migrate out of the building. I'm not going to get into that. Personnel training is extremely important. And for those of you in the industry, there are many training certification programs out there. You can go through SEMA, Snow and Ice Management Association, American Public Works Association has a snow supervisor certification program. Your staff gets trained in how they should be handling snow and ice control operations and what's the most effective way to do it. And there's nothing better than having your staff certified. And the other thing is, and I'm not going to get into this too much, but if you don't follow applicable standards of care, national standards of care for snow and ice control, you can put yourself in a liability issue. And like I said, in my current position, I get many cases where we're going after towns and counties and contractors because they did not follow applicable standards of care for snow and ice control. And if an attorney can show that when it involves a municipality or state or stuff that they didn't follow that and they were negligent, this government immunity that is often assumed can be bypassed, and they can be pulled in and sued. Educating the public is another thing. The public, we should be completely transparent. The public should know what's going on. They should know, in their terms, as a public audience, what snow and ice control is, what's the reason for applying salt. I think most of you should know this, but the purpose of applying salt to a roadway in an anti-icing situation is to prevent the snow and ice from bonding to the road. That's anti-icing. If you prevent that, then you're able to just plow off the snow and then reapply chemicals after that. Once you get that bond that occurs, if you don't anti-ice, once you get that bond, it will take you, and this is published information, it will take you at least 4 times more salt to de-ice versus anti-icing. And the cost-benefit ratio, the cost-benefit of anti-icing versus de-icing is 11 to 1. So significant cost savings in doing anti-icing. Educate the public, and I'll get into this a little bit with the GIS, but we were so transparent in Hamilton. We put our entire snow and ice control database out there, our GIS, so people could go onto our website and they can actually see the plows, where they are, what they're doing, how much material they're putting down, all that things. And then we had something called Snowplow Sal, where they could actually, because we had a plan, they could actually type in their address and it would tell them when they could expect to see a plow or a spreader on their road. So all kinds of things to do. I don't have enough time to go into tremendous detail on all of those, but if anybody wants to, I have my phone number at the end, I think. You're welcome to call me. So what is anti-icing? Anti-icing is the application of a chemical freezing point depressant to a roadway before or at the start of the winter event, and it's there to inhibit the formation of the snow ice bond to the pavement. That's what everybody should be doing. Anti-icing prevents the snow and ice from bonding to the pavement. It's a proactive approach. De-icing, you're applying chemical after you already have snowpack and ice. It's a reactive thing. Studies have shown that it can take 4 to 8 times more salt to de-ice than anti-ice. Anti-icing can provide a higher level of service, keep snow in a plowable condition, can provide bare pavement during the snow, and a minimum anti-icing results in achieving bare pavement at the fastest possible rate at the end of a storm. So if you're anti-icing, the storm's over, and all you got to do is come out there with your plows and push it off. It's a very, very good thing. And here's that cost benefit of 11 to 1. And these aren't my numbers. This is easily accessible over the internet. Anti-icing with liquids. So just about everyone, not everyone, but just about everyone is using liquid applications, and they pre-treat their roads ahead of a storm. And you can either use salt brine or salt brine blended with other chemicals. Roads, bridges, hills, critical intersections, all great places to do this anti-icing with liquids. And important part about this is clearly if you need to know what the weather forecast is, because you don't want to anti-ice pre-treat the roads ahead of a storm if the storm's going to start out as rain, because it's just going to wash away. You don't want to do this if there's just a low probability of snow and ice. So it's a lot of things to look at here, but it is your first spread. It's going to save you if you do this anti-icing apply before the storms. It's not critical to have your men in immediately as your staff in immediately before as the storm starts, because you've already got your first spread down. So it's also an insurance policy, and it's absolutely can cut down on the amount of overtime involved. So liquids that you can put down are sodium chloride, calcium chloride, magnesium chloride. I've also used potassium acetate when I was at the state, when I was doing some research. And then agricultural byproducts such from sugar beet and corn are also used. And they act as cryoprotectants, these agricultural byproducts, because although they have no melting ability, when you put your brine down, it helps the brine stay on the road longer, and it slows down the formation of ice crystals in the liquid as the temperatures and the brine gets diluted. So it's a money saver, and it improves performance, and it's a natural anti-corrosive. Sodium chloride has become the liquid brine of choice for pre-treating highways and roads due to availability and cost. And mixing, I'm going to get into that a little bit, but you can mix chemicals with your brine like calcium chloride and magnesium chloride, to provide a lower freezing point. So just some brine facts. I'm not going to go over too much of this stuff here. It's just for your information only. Pre-wetting accelerates solids going into solution. So if you put down salt in a storm where the temperature's 20 degrees and you're just using plain salt, for example, it's going to take a long time for that to go into solution because of the coldness. And when you got cold air, you got dry air. If you pre-wet those solids, that acts as an accelerant to help get the salt into solution and make it work. Salt, as everyone should know, does absolutely nothing until it becomes a liquid. So the salt just sitting on the road does nothing. It's got to become a liquid. Pre-wetting can significantly reduce chemical application rates because more salt is staying on the road, and because it's going into solution quicker. Also, this anti-icing has been proven to significantly reduce the amounts of accidents involved in snow and ice control. Technologies and regulations. So electronic ground speed controlled spreaders. So if you're riding down the road and you're applying 300 pounds per lane mile, you slow down or you speed up, the application is automatically adjusted based on your speed. Zero velocity spreaders. Talked about that earlier. It's where the spreader is actually closer to the road. You get lower, less bounce. A lot of agencies are also using rubber plow blades. Recycling equipment, wash water covered that. Not going to get into snow fences. I could be here for an hour just talking about that. Anybody who knows anything about snow fences, though, should know that this fence itself should not be sitting on the ground. It should be roughly 6 to 8 inches off the ground. There have been studies done to show that that's the best way to have drifting stay near the snow fence and not actually blow out closer to the road. Okay. Yep. So some agencies, I think Massachusetts was one where they have no salt zones. You can't apply salt. And look at different types of alternatives. Like I said, there's different chemicals that are decent for the environment. So here's some salt storage pictures. Here's a truck wash station. A couple of pictures there. This is an environmental basin. You're seeing more maintenance facilities, especially at the state, where they're being built, and there's these environmental basins, and the runoff from the facility goes into the basin, and this vegetation actually cleans the water and removes core eyes and things like that. So decision making, it's extremely important to know what the weather forecasts are. Start and end times, pavement, ambient, and dew point temperatures, intensity, precipitation, the type of precipitation, what are you going to do with winds, monitoring the conditions. If you're a state, you may have access to road weather information systems. If you're not, or if you're everybody, you should have mobile pavement temperature sensors in your vehicles, so you can monitor what the pavement temperatures are. No reason to put chemicals down if the pavement temperature is 40 degrees. Refractometers. So that's something we're going to get into a little bit about how you can use refractometers to help you decide when to reapply chemicals, because these refractometers, you take a couple drops of liquids off the roadway, put it in the refractometer, it'll tell you what the salinity of the brine there is. And if you know that and the pavement temperature, that gives you an intelligent way of determining whether to reapply chemicals. Sounds a little complicated. It's not. Every one of my crews in Hamilton had a refractometer. They cost a few $100 a piece. Maintenance decision support systems. That's a system where all this information gets pulled in, and then it will tell you, recommend to you what you should do, as far as how much you should put down, material you should put down, that type of thing. It's based on the storm event type, precipitation intensity, all those things. And everybody should know exactly what they're expected to do. So, how much material to put down, all those things. You shouldn't be having a truck out there just bombs away. I mean, everybody should know here's what is expected. Prepare route by route spreading and plowing plans. Went over that a little bit. Extremely important. there's actually software out there now. And I think some of the companies like the waste removal companies and things like that, they do that so that they can get their waste picked up as quickly as possible. So they have optimized their routes that these trucks travel. We can do the same thing for spreading and plowing, and it could be, and it could be set up to, and it does get set up. So if when vehicles are down and not available, it adjusts the plan automatically based on what equipment you have available and the size of the trucks, etc. Prepare facility spreading and plowing plans. This is to deal with parking lots and sidewalks and all that other stuff. Determine, this is where it gets a little complicated, but determine resource requirements. So I know, when you're determining what do I need to really effectively do snow and ice control, how much equipment and that type of stuff. Now you've got to obviously you have to get money from your town or state or stuff in order to buy stuff. So I could spend hours just talking about this, but it's important to do that. What do you need to get the job done? And then echo that to upper management. And if you can't get the equipment, then you have to adjust your plan so that you do it with whatever you have available. So a computerized maintenance management system, and consider also using GIS and AVL. Extremely important as far as I'm concerned. I'm going to show you some photos of stuff in a second. Track vehicle usage and salt quantities. Again, it's good to know, where your vehicles are, what they're going to be doing, and how much material they're actually putting down, and record all that information. And it's a good way, if you can track it and you see that there's certain vehicles that are putting way too much material down, you're able to talk to the driver and educate them, that type of thing. Establish a communication system. Use an operations center. I don't know how many people are doing that. I know pretty much all the states use that, where they have people staffing a center and they're able to track operations and what's going on. Decision-making tools. Forecast, extremely important. If you have access to RWIS, so road weather information system, and RWIS is actually an automated weather station out on the road. There's pavement temperatures, you got wind speed, precipitation intensity, all of that stuff is being captured. And if you're a town, where everybody's paying taxes, if you're a town, you can often convince the state to give you access to their road weather information system. Now, it's not your road, but you can still see what the weather's going there. You can't really use you can use the pavement temperature stuff, but obviously everything as far as how much chemicals there and things is really not going to be useful. But you can reach out to your state and very well could get access to RWIS. I know when I went with Hamilton after the state, I had access to the NJDOT RWIS sites. Equipment and personnel readiness, that should happen year round. Public relations and public education, very important that the public knows what you're going to be doing. Pre-storm strategy meetings and post-storm strategy assessments, a requirement in the plan. So before a storm comes, and a storm's coming based on the forecast, you should pull in all your key personnel, have a pre-storm strategy meeting, say, okay, here's what they're telling us is coming right now. Here's our plan. Here's what we're going to do as far as putting material down. Are we going to pre-treat the roads a day ahead or 2 days ahead, whatever it is? And then here's what we can expect throughout. And often when I did these pre-storm strategy meetings, I would actually call up the weather forecaster and have them on the phone, just so everybody knew exactly what was going on. And then post-storm assessments, you do it after the storm and talk about the things you did right and wrong. Levels of service. So what's expected, and this is where everybody needs to know. So there should be primary roads. Obviously, we have primary roads. We have secondary roads. The primaries, which get the most traffic are obviously the most important. So what is your level of service for primaries? Is it to try to maintain a bare pavement throughout the storm? Sometimes you can, sometimes you can't, but at least at the minimum, any snow that's accumulating, you can keep it in a plowable condition if you anti-ice. But it's important everybody knows the levels of service for different roads. So roads can be classified in many ways. In my town, we did primary and secondary. The secondary were the neighborhood roads, the primary were the main roads, and often the main roads going into development, so you easily could get, emergency vehicles in and out. And you could use that same philosophy for buildings, sidewalks, and parks. So obviously the mayor's office is going to be a priority over, a park. And that was just an example of that. So some funny things here. And I always refer to the bottom when I say, there's so many resources out there. If you got a good police department, you could probably get some of them to help you too. That's not going to happen. I think these are hotel people. Forecast, important to have important to have start and end times, 24-hour pavement temperature forecasts, dew points. You want to know if there's going to be condensation forming on your bridge decks, and what's going to happen after the storm, or the temperature's going to do. So here's an example of a 24-hour or close to that pavement temperature forecast, which includes ambient pavement temperature, all those types of things. How do you decide when to apply or reapply chemicals? So many are just, it's intuitive. You apply chemicals and then you come back out and you say, okay, yeah, it's been a little while, let me put more down. That's intuitive. Some people are really good at that, others aren't. Lapse time since the last application. So if you apply salt and now a certain amount of time has gone by, you could just say, okay, it's time to go back down and reapply. Again, intuitive. Technology, you can use technology. RWIS, there's ways to measure skid resistance, refractometers, which I talked about a little bit, maintenance decision support systems. Now, this is a picture of an RWIS. You've probably seen it before. You got a weather tower with a weather station. Here's the sensor on the right is measures the salinity of, measures the pavement temperature, the salinity of the brine that's there. And if you know what the salinity is and you know what the pavement temperature is, you can determine if you need to reapply chemicals. This is a typical ambient surface temperature device that you can put in your vehicle. It uses infrared technology, and it gives you the pavement temperature and it gives you the ambient temperature. And I'm going to say this again. There's nothing more important to you if you're involved in snow and ice control operations than what the pavement temperature is. If the pavement temperature is below freezing and you've got precipitation, you're going to need to do something. If it's not below freezing, any material you put down is a waste. It's just going to, the snow's going to melt, everything's going to get diluted, it's just going to wash away. So very, very, very important to know what the surface temperature is. And these devices are relatively inexpensive. Every vehicle in Hamilton, in my town, every vehicle, pickup trucks, loaders that we use for plowing, dump trucks, all of them had these devices in them. This is a refractometer. And again, it's just a matter if you want to see what the salinity is of the brine on the road, you just pull over, take it, it's got eyedroppers, take an eyedropper full of material, put it in that little cup, close the lid, push a button, it will tell you what the salinity is. You know the salinity and you know the pavement temperature, you can determine whether you need to reapply chemicals. This is a skid resistance. I don't know anybody that uses this, but you can also determine the reapply chemicals based on the skid resistance. Maintenance decision support systems, something where you can actually, it takes your forecast information, it takes information that you have been inputting, and it tells you what you should do, or suggests what you should do. So I've already talked about some of these other devices that you can use to help you determine when to reapply chemicals and take it out of just pure intuitiveness. There's all types of technology out there. Things you know, anti-ice will work until the eutectic temperature of the solution meets the pavement surface temperature. So when you anti-ice, it's important to know, how much, what the salinity is, because that, and what the pavement temperature is, because if it gets too diluted, then it's going to refreeze. So refreezing occurs when ice control chemical dilutes and melting stops at a given surface temperature. again, some of this is technical and I could go on for a long, long time. So I am absolutely, if anybody needs to contact me later about this, I'm open to it. MDSS, knowing the weather forecast, pavement temperature, etc. You can use an MTS to suggest or recommend the best recommend decisions that you should be making with regards to the storm. You can also use graphs to determine when to reapply chemicals. I've used this before we got into major technology, and it gets you away from this intuitive stuff and gives you a more educated way to make a decision. Salt brine application guidelines. This is things where you can use MDSS and you can determine, okay, here's the type of storm we're expecting, here's what the pavement temperatures are going to be, and here's what we should do. Application rates depends on your number, what equipment you have, but typically 40 to 80 gallons of materials used if you're going to pre-treat your roads. And then there's different rates that you can use depending on the storm type, as far as reapplying solids after the brine. Another example of a weather forecast with pavement temperatures, etc. Equipment readiness. I'm going to not go through this in too much detail, but spreader calibration is extremely important. You shouldn't be putting down 800 pounds per mile when you really only want to put down 3. And again, this is old information, but Hamilton Township calibrated all of its spreading equipment twice during the 2004-2005 winter. During that winter, Hamilton received more events and 6 inches more snow than for the previous winter, and we saved $160,000 in salt compared to that previous winter. And there's all other kinds of factors that go into this, but this is a fact. So this winter operations in 2005, we developed this winter operation geographical information system. System allows us to track our progress in fighting winter events. You can see every single plow that's out there on the roads. You're able to see it. You can see if the plow's in the up position, down position, how much liquids are they applying, how much solids are they applying, what is the ambient temperature, what is the pavement temperature. Very, very important in my opinion, and all kinds of ways where you can do this at a relatively minimal cost. Oops. So it also tells you vehicle speed and all that other stuff, and get a breadcrumb trail of what the vehicle did afterwards. We had a complaint. There was 13 mailboxes taken down on one road, and we just went into the GIS and found out what trucks were there and when they were there, and we didn't discipline anybody. We just they were going too fast and it was a heavy snow, so we just had a little chat with them and that was it. But you can get all kinds of information from this. Real-time tracking, all kinds of sensor data. Okay, and you can also set red flags up. So if any truck spreads over a certain amount of material, it will notify you that this truck is spreading 500 pounds per lane mile. And if they're going faster than they should, it can also alert you of that. This is Hamilton's Operations Center. And these are just some maps that you get there, and it shows the trucks, and you can get the information here. It tells you the truck number, all that other stuff. Another one. And this is like a dashboard that tells you where you are in your snow and ice control operations, how many of your roads have been spread, how many have been plowed, what's remaining to do. So, and then training, very, very important. I love snow rodeos. This is at our ecological facility that we use this to train trucks on. In the summer, new employees can come in here and we spread mulch out and they can plow the mulch. So this is in the old days. You see the wheels on this plow. It's an old plow. Today, the plow just rests straight on the roadway. That's what everybody should be doing. The plow should be directly on the road, removing as much dilution potential as possible. That'll keep you in an anti-icing situation, reduce the amount of salt you use. Snow rodeos are an absolute blast. So I don't know if you've ever done any, but this is an obstacle course where the vehicle goes through the cones and You have a barrel push at the end, and there's all kinds of stuff. I don't want. So you can reduce if you follow a plan, natural plan. You can reduce the amount of time it takes you to spread and plow your roads. So if you have an optimum roadway spreading and plowing plan, you can significantly reduce the amount of time it takes you to get the work done. And like I say at the top, it was taking 3 hours or more to spread all primary roads in Hamilton. By following a detailed plan, we cut it to 1 hour and a half. Significant. And if you can follow those cycles, that means follow those cycles. It typically is going to mean that you're going to be using less salt, because you're not getting that buildup of snow, and you're keeping it in a plowable condition, that type of thing. And plowing, significant difference in plowing at the plowing point, 10 to 12 hours, and we cut it to almost 6. Secondary roads, part of the plan, it was taking 36 hours or more to plow all of the secondary township roads. Using a plowing plan, everything was done within 24 hours. This is the neighborhood roads. Just a summary. I'm not sure how much time I have left, but just a summary of things. And there's all training programs out there. If you're a American Public Works Association member, the training is free. And I really think it's extremely important that you spend a little bit of money and send your people to training, to become certified snow fighters. Not only is it going to be educational for them, but it's going to reduce your liability in the event that there's something happens and that your town or whatever gets sued. You can say, well, look, all my guys were trained, they're certified, and there were other factors involved. So it's a good thing to do if you can. Don't use sand or abrasives unless absolutely necessary. Apply the right material in the right amount at the right time. So try to make it as cookbook as possible. You always got to make adjustments, but try to make it so that here's what's going on, here's what we should do, here's how much material we should put down, that type of thing. So, and then the other thing, I'm going to just take a moment here. Right amount in the right place. So the last couple of storms, minor events, my streets were spread, and I'm going to say that 10 to 15 feet of my property with salt was thrown on. And I walk my dog all the time, so I'm down there, and here's the salt on the sidewalks, and it's also on. You can see when there's snow, you can see the little salt marks where the salt went. So on a roadway, you want to try to focus the salt. If it's like a 2-lane road, let's just say it's a 2-lane road and it's crowned, you want to try to focus your salt application to the middle of it, because it's going to run off to the sides. You don't need to spread the shoulders and the adjacent property. So you adjust your spinner speed and you can keep the salt in the middle. That's going to save significant amounts of chemicals, because you're not throwing away half the chemical off the road. And again, when you're applying this stuff, pavement temperatures are critical. So if you don't have pavement temperature sensors, I would think it'd be a really good idea. They're not expensive. And pavement temperature forecasts are something that you should get. And if you don't have the money to do that individual vendor-based forecast, then what you should do is go to your other towns around you, and you could have a regional pavement temperature, a regional forecast, so that the forecast applies to everybody. So you should do a shared services type thing. That saves significant amount of money. Don't apply pavement temperatures when they don't apply chemicals when pavement temperatures don't warrant them. Like I said, there were times in Hamilton where we didn't put anything down, where others were putting material down. And it was because we knew the pavement temperatures were above freezing. Based on the pavement temperature forecast, they weren't going to go below freezing. So try to be as smart and intelligent as you can, using whatever information you can get. Anti-ice pre-treat roads were applicable. Okay. This is just a quick summary. Proper storage of salt and sand. Calibrate and recalibrate equipment, extremely important. There we go. Educate the public. It's good that they know what to expect. And if you use that GIS that I was talking about, the GPS, we would get calls saying, "Oh, your guys never spread our street," and then we just go into the GIS and say, "Well, they were there at 3 o'clock in the morning and they applied 300 pounds of salt," and then they don't say anything, and we could tell them the truck and a truck number and a whole bit. So very, very important. We've also used our GIS where we would get calls. There was a heart attack victim, and we were able to redirect the closest vehicle to get over to that residential street and make sure it was plowed so a vehicle, emergency vehicle, could get in there. All kinds of great things can be done. Talked about wash vehicles, store liquid.
Rich,
Okay.
we actually had a question about washing the vehicles. Is it okay if I start
Yeah, go right
launching
ahead.
into some questions? Okay, awesome.
Yeah. I'm almost done anyway, but go ahead.
Yeah. Oh, so with that, with washing vehicles specifically, there was a question about if there's any best practices to remove dry salt from the trucks before washing them with water, because, once the chloride becomes aqueous, it's really hard to then take it out.
Yeah. Oh, yeah. So if you've got a dump truck and there's still some dry material in there, maybe it's stuck to the body, then it's a mechanical thing. You get up there and you use shovels and brooms to remove it, let it go out, and then you just put that salt back into your salt storage area. So that's a good question, because a lot of times, the bodies get wet and you'll get the salt, like little clumps sticking, especially in the corners. So what you do is you have to, you should somebody would get up there and just shovel it off. Take a shovel. Typically that's what they use, and they break it off. It would fall out, and then you can just scoop it up and throw it back in your pile.
Okay, great. Thank you. And there was another question about pavement temperature forecasts. Is there a place where people can access this information for free? The forecast?
Well, no, not so much the forecast. That is so. So if you are well, yes and no. So if you're a town, for example, like Hamilton, again, I'm a proponent of transparency. So you're a taxpayer, you're paying for everything, including any weather forecasts they get. So when I was the director of public works at Hamilton, everything was available on their website. So if you wanted to see what the forecast was, what the pavement temperature forecast was, you could go to the website and you could get that. And it would tell you when precipitation was supposed to start, what kind of precipitation was going to be. You would have all that information readily available. But not all towns want to be transparent. Not all DOTs want to be transparent. I think it's important to be transparent. Keep the public educated, let them know what's going on. Just like I mentioned with our website, we have Snowplow Sal. If you wanted to know when your plow or spreader was going to be your street, you just typed in your address and it would tell you approximately when you could expect to see a truck there. That's all based on the plan that had been put in place. So it's a yes and no answer, depending on the philosophy that your town covers. Now, there are sites out there that will let you access all the road weather information systems that are out there in the country, but it's not always in real time. But you can access them. It's not giving you forecasts. It's just giving you what the actual pavement temperature is at that location. I know Iowa University maintains a clearinghouse of that stuff. So, but the answer is yes and no. And if you want that and your town does get a pavement temperature forecast, you could tell your town that I want to see this forecast. I'm paying for it. You're the taxpayer, and please put it on your website. So, but it's a yes and no answer. So some towns do it, others don't, and I think everybody should do it. It's good information for the public.
There are a few other questions here, but I can let you finish your wrap up before we get into them.
Just about done. So again, I'm not going to keep harping on this. Anti-icing, anti-icing, anti-icing. Don't allow snow and ice to bond to the pavement. You're going to have to put a tremendous amount of additional chemicals, 4 to 8 times more chemical down once you have to go to a de-icing situation. Now, de-icing doesn't mean that there's snow accumulated on the road. Okay. De-icing means the snow and ice that's accumulated has bonded to the road. That's de-icing. If it's just accumulating on top of your brine or whatever, then it's plowable. So you just come along with a plow, the plow blade's laying flat on the road, and you just push it off. So anti-icing, extremely important. Keep everything in a plowable condition. Okay, keep your plow blades on the ground so you move as much precipitation as possible to reduce the amount of dilution. Pre-wet, always pre-wet solid materials to reduce bounce, keep the material on the pavement. Identify salt-sensitive areas. Again, if you've got an area that's salt sensitive, you can come up with a plan to help minimize the effects there by either using a different chemical or don't apply anything. Alternative environmental friendly chemicals are out there. Winter maintenance management plan. If you ever want to see this, you can either call me or call Hamilton, and I'm sure they would be more than happy to demonstrate their system. It is state of the art. It's a great system. I'm not taking full credit for it, but it was me. I brought liquid applications to the state, also to the town, and I also was involved, the key person in setting up this GPS, ABL, and GIS at Hamilton. It's something to see, and I'm sure they're more than happy to showcase it for you, especially if it's a winter event. You just come in and you stop when you watch it. Go to their operations center, and I can't emphasize this enough. There's so much state-of-the-art technology out there that can reduce the amount of chemicals that you're putting down, such as ground control spreaders, infrared mobile pavement temperature sensors, the refractometers I talked about, etc. This is just a quick overview of things we already covered. Your staff should know how to calibrate equipment, unless you let your mechanics and garage do that. And I can get into brine concentrations, but the optimum brine concentration is 23.3% salt by water. And I just talked about, here's just a summary of training programs you consider doing. Understand the principle of refreezing. Again, this is important too. So if you're plowing your parking lots, make sure that you have a plan on where you're going to store the snow. Otherwise, the snow melt is just going to go across the pavement and refreeze at a point. So if you store your salt in snow in the right spots, it can be set up when it melts. It just goes into a storm drain. Store your plowed snow into a storm drain, and you'll minimize the adverse effect of refreeze and the amount of chemicals that you have to put down. If it's not coming across the roadway or the pavement of the parking lot, then you don't. If it refreezes, you're not going to have to put chemicals down. So, again, a big just summary. Salt management principles of ice formation. Know how ice forms on roadways. Especially you should understand how things deal. Bridge decks, because the underside is exposed to the air. How bridges can freeze beforehand. They're an excellent source of pre-treating. If you don't need to pre-treat the whole road systems, maybe you just have to pre-treat your bridge decks. Understand the science of freeze point depressants. How does brine work? That type of thing. This is all stuff you can get out of all these great training programs. Understand how frost and black ice forms due to dew point conditions. Again, those are things that forecasts can tell you, that the dew point conditions and the pavement temperatures are going to be. When dew point and pavement temperature are close together, you can get condensation forming on the pavement, which can freeze if the temperatures go below freezing. So these forecasts can actually tell you that stuff, these pavement temperature forecasts. So okay. Brine production use, know how to make brine. A lot of these systems now, you just push a button and it makes it themselves. You can make it manually also. Anti-icing. Understand how to fill spreaders and anti-icings with liquid chemicals. Understand the health, safety, and environmental precautions need to be taken when handling liquid chemicals. This is all kinds of stuff. Some of it is clearly related to uh, water pollution, but others are just information that would be useful to you. Road salt in the environment, understand how the I just remember how harmful it can be to vegetation, how damaging it can be to aquatic life, those types of things, and why it's so important to make sure that you put down the right amount of chemical at the right time and at the right place. It's so many agencies have this zero tolerance things, and it's bombs away, and that's why you see the roads white with salt, where you see the shoulders covered with salt. I used to joke when I did my presentations for Rutgers and University that I would jokingly say, we're sending our sweepers out on these roadways, and we're going to sweep the shoulders, and we'll have enough salt to get through the entire winter. And I was joking, but there's a lot of salt out there that just bombs away, never gets a chance to go into solution. So picture this: if you had a glass of water, if you had a glass and it was filled half with salt and you filled the other half with water and you stirred it, how long would it take you to get for all that salt to get dissolved? The answer would be never. It would go on, you'd stir forever and ever, because it's a solution. And once it reaches its saturation point, none of that other salt can go into solution. So it's the same thing with putting salt in the roads. If it doesn't get to go into solution during a certain time frame, the salt's going off the roads and going into the environment. So that's why it's so important to put the right amount of chemical down at the right time and in the right place. And that's why all this other stuff, weather forecasts, all that stuff, everything goes together. Calibration, the whole bit.
There are some questions from folks in the group who are from boroughs that are small and they don't do their own snow and ice removal, and rather they contract.
That's okay.
Contract it out. And so there were some questions about what are some questions that they should be asking their contractor to make sure that they're going to salt responsibly. And kind of a connected question to that is there a good way to find contractors who follow these guidelines?
Yeah, well, the first thing to do is when you write the contract for these contractors, you put this stuff in there. Here's what's expected. You have to have, so if you're just calling a contractor and you just say, okay, that's it. I called you out. I'm now done. Do what you're supposed to do. Not good. You still have to have control over your contractors. So both at the DOT, when we would bring contractors in, we would have what we called a snow rep. And there'd be one person who would actually go out there and direct the contractors, follow the contractors around, make sure that they did what they were supposed to do. And you can require those contractors to have things like ground control spreaders, have pavement temperatures, and then put a system in place where they need to follow these rules. All that would be included in the contract. And even at the township, we had the same type of thing. We would bring contractors in, but they were merged with our own people and directed by our staff on what to do. So you can still have a maintenance decision support system, those types of things, and you just put in there, this is what they have to follow. So I don't know enough information about that, these boroughs. If somebody wants to call me, we can talk about it and I can give them some ideas. So the question is, though, do they just bring their contractors in and then, slap their hands and say, okay, I'm done. It's all on them. That should not happen. You should still have some control. And again, a lot of these contractors they're just, even the contractors, a lot of times it's bombs away with them too. Salt's not expensive. And, but that's an outstanding question. And, but
we had someone in the group share a link actually to a model contract, and this is from the state of Minnesota. So there's some great examples in there of things that you're talking about to include in your contract.
Yep.
And then also another question, there's so much information in your PowerPoint. I'm wondering if we can have a copy of that to share with the attendees today so they can kind of dig through it a little bit deeper.
I uploaded two PowerPoint presentations. One was,
and I can send those out, and that's good.
Oh yeah.
Oh, perfect.
Okay. This one had like 98 slides. The other one had like a couple hundred slides.
Yeah,
So yeah, and it contains a tremendous amount of information, and they're more than welcome to share all those PowerPoints. And like I said, um, I'm more than happy to take phone calls from people after this is done, whenever they want.
that's
Um,
great.
so
Yeah, thank you. Thank you for that. So there was one other question, kind of group of questions that I wonder if we can tackle, and then we've kind of reached the end of our
yep,
time here. But so these questions are related to the cost benefit and trying to kind of explain to your municipality that it's worth it to explore these smart salting strategies. So the
yeah,
question was, do you have any hard data to show this is how much we can save, and this is how long it would take for us to, get our money back essentially for these investments? And
what
I
a
think you had some of that information in your slides.
what a great question. And I went through that exact uh, process. So when I came to Hamilton and I got the director of public works, and I wanted to bring things like brining and all this other stuff to the town, I actually prepared a cost benefit analysis justifying this stuff, and I presented it to council. I got a lot of negative feedback, but in the end, I convinced them that we could do a two-year payback. We could have the system would pay for itself in 2 years, and I never want to say something that's not true. And I did that, and the system paid for itself the very first year. And this is going with a
That's
brine
amazing.
making system, and the money that you can get. There's money that a lot of people don't even think about, but like when towns like buy trucks and things like that, they'll put things out to bid, and they'll estimate how much it is, and they'll have money available to buy the truck, and then they get the bids in, and they're able to buy the truck for less than what they expected. So there's usually money laying there that you can get and take it. And that's what we did in Hamilton. We took that excess money that was sitting there, and we did all this work that we wanted to do um, with regards to updating our equipment, getting a brine making system put in, and equipping our trucks with brine tanks and stuff like that. So all kinds of ways to do things. And there's money. You just got to look for it in the right spots. But that was a very, very good question. I did a presentation for University of Wisconsin on that at one point. So maybe I can throw that up there. It doesn't cover everything, but like I said, I had to go before my own council and make a presentation on how we can do this, improve our services. So this is the beauty of this. It's improve services at less cost. I mean, how could you say no to that? You're
Mhm.
improving services at a reduced cost. You're making the roads safer for the public. And they went with it, and there's never been a regret.
Yeah,
And
I mean, it's the triple bottom line. You take in the
yeah,
environmental benefits as well, and
that's
it's a
right.
win-win-win.
It is to win-win-win. So yeah, so maybe I'll try to find a way. I'll upload that too. Um,
I'm
but
sure people would
and
appreciate it. Yeah.
and I can see what I can find on actual data, more data that's out there. But there's no question about it. It's in my presentation. I don't make up those numbers. Those numbers came from uh, sources. Usually, I show those sources in my presentation.
Sure.
So let me just go through this. There we go. So here's just a special alert. Um, going to be a lot of snow in 2025, 26, and expect some ice too. And that's it.
Thank you so, so much, Rich. If
Yeah.
you'd like to put your number in the chat, then the folks who are on the Zoom call now, they can have access to that and maybe reach out. But your email address is also on the screen, so
Yep. That's
people
probably the
can.
best way to get a hold of me is email me, tell me you want to talk to me, and then
Yeah,
we'll set something up and we can talk. But I'm
yeah. We
more than
don't need
happy
to
to.
blast your
And
phone number all over the.
right, and that's okay. And the other thing I offer, and it depends on how many people. I'm not going out. Minnesota's a great state. They do good stuff. Iowa's really good. I'm not going out there, but if there's anybody in New Jersey, any towns in New Jersey that are here, I am more than happy to come in and do a short presentation for them at no cost. So if they reach out to me and we're able to arrange something, I'm more than happy to do. This is so important to me. I'm more than happy to do some training and things like that for free.
I'm sure we'll have some takers on that.
Yeah.
And thank you so much for your time today, for sharing your expertise, and for the expertise I'm sure you'll be sharing with us in the future as well.
Great.
Um, Thank you to everyone for attending, and I hope that we can all kind of learn from this and really start to make some changes so we can reduce freshwater salinization. This is all, like
Yep.
we mentioned, for the triple bottom line. So
And
we're going to call it there. And
just let me can
oh,
I'm just
sure.
going to say one more thing.
Yeah, absolutely.
Getting weather forecasts specific to your area, um, and getting pavement temperature forecasts is critical. And you can put a contract together if you want to reach out to Hamilton Township. They've done this. We put a contract out. But if you're in New Jersey, and even if you're in, other states, for example, if you're in New Jersey and Hamilton has a weather forecasting service with a vendor, okay, then other towns like Ewing, Lawrence, Princeton, those types of things, if you want to reduce your costs, if it's too expensive for you, because there's a lot of these like Princeton Borough, smaller entities, you really have limited funds. So what you do is just go together with these other towns and create a shared services agreement and rewrite the contract. Now you're getting weather forecasts at a significantly reduced rate. So there's all kinds of ways to do that. And even when it comes to brine making, some entities have a system in place to make brine. If you don't want to make your own brine, talk to that town and maybe they'll make the brine for you. And all you got to do is go pick it up. So all kinds of ways to do things. And again, I'm more than happy to share my thoughts and stuff with anybody. So I appreciate it. I know I did a little bit of rambling and I was talking very, very fast, but
So much to share.
yep. Okay.
All right. Well, thank you so much, Rich.
Yep.
And we'll see you soon.
Okay.